Hi everyone, my name is RajeshPahari, and yeah, I would like to start my presentation for my final project for ADTA 5900. So for the first part, the professor has asked us to get a time series data somewhere from online, and look at the data and tell us like what kind of data types we have on the data, as well as provide the link to download the data. So what I did was I went to Yahoo Finance, and here's the link for Yahoo Finance. And I went in there and I downloaded the historical financial data for Microsoft corporations between January 1st, 2014 to June 30th, 2019. So, and it's a CSV file. It will be provided to the professor along with my submission. And when you look at the file, and when you open it, you see that it has this kind of attributes: open, high, low, close, and adjacent close. These are the numerical floating type of data. And the volume, that's the number of count of stock sold. So that's an integer data. And like I said, open, high, low, close, and adjacent close, the stock price value for opening time, the highest for the day, the lowest for the day, the closing value, and the adjacent close values. And additionally, I pull that CSV file into the Jupyter notebook, and I read through the data. And here's the data frame. When you do the print data frame head, it gives you the first 5 rows. And when you do DS data frame describe, it gives you the summary statistics for the attributes. So we have like 6 variables. So it is the summary, and then when you do data frame shape, what it does is it tells you how many rows you have. So how many rows and columns we have. So we have 7 columns, one of them being the date, and we have like 1382 entries. Those entries are 1382 business days within the time frame that we provided. So that's pretty much all about the first that part. So let's move on to the second question. That's about the simple RNN neural network with sine wave data. So, all right. So before we begin with this, let me give a brief overview of what we are trying to do over here. So what we'll do is a sine wave is a time series data too. So what we try to do here is generate the sine wave data, like you get those values and provide them into the neuron simple recursive neural network layers, and like train those data, build the models, train the data, and be able to predict the next data using that. So so here's how the diagram looks. The architecture diagram looks like. We have a simple RNN, and we have a fully connected network. And on the simple RNN, we plan to have like 50 neurons. And for the previous states and biases, we plan to have, we'll have like 64 of those. The reason we don't have 64 of those is, we have like 64, we'll provide 64 inputs. And then like these are connected to the fully connected or dense network, and then like we make a prediction from here. So like I said, we have like 50 inputs, and we'll have 64 neurons of RNN. And the reason there is only one output node is because the prediction problem is for the next data in the sequence. So we are just going to predict one more data. So so we just have like one output node defined on the dense parameter. So now we build a model, we train the model, and in the end, like this is how we observe the graph to be. So the one and two, it shows what was the actual data provided, for the, and on the yellow, the orange one, it shows the predicted data. So all right, so let's go through my Jupyter notebook, and I think it will be easier to explain that way. So first thing we do is we slice everything between 0 and 50 into 7/16 pieces, and then the y is evaluated using each of those values for x, and so y is the sign values, and when you plot x and y, that this is what you see. Those are the sign values. And next thing we do is we split. We plan to split y into training and testing data. So for the test, we provided 20%. And because we have 768 available points, that makes it 153 or 154 data points for testing, while 615 for that's for training. Now, so our training testing index will start from 615, and all right. So next thing we do is we scale all our training data, and we normalize both our training and testing data. And the next thing, we select the length of the number of data to be utilized to predict the next data to be 50, and so using the time series generator, and those are the 50 data. And those, now next thing we do is we build a model, a sequential model. We add a simple RNN and dense, and as you can see, the simple RNN is using 64 neurons, and on dense we have 1 because we are just going to predict one thing. And we compile the model. We see that the parameters we have 40 to 89. An important thing when you compile the model is that we have using the optimizer as Atom and the loss as NSE.